All right. Well, welcome everyone to our 2020 Intuitive Client event for this pandemic edition that we are running today. Normally, this time of year, we would gather with our friends, clients, collaborators, and talk about what's coming up. The year we've had at Intuitive, what's coming up in our industry, and look ahead to the future. And of course, this year, so a little over 7 months ago, we were all forced to turn into video talk show hosts and participants. And so this year, we're hosting this on the Teams platform. But it is giving us a unique opportunity actually to expand our reach. So good afternoon or good morning, depending on where you're joining us from. And we do have speakers from Toronto, Edmonton, Vancouver, all of which would be very difficult to do if we were meeting in person. And we can all do this where it allows you to get extremely close to my head without, uh, you know, bucking any of the social distancing protocols that we have to follow these days. Today, our topic is shaping the built environment of the future. And we're pleased, really pleased to be joined here by six industry experts with whom we are proud to be associated with on our journey at Intuitive of uncompromising performance. So we have six speakers, about 6 minutes each, and then it's over to you for questions that you can submit directly to Allison Wood via email. And hey, we have prizes for the best question. We have an all expenses paid 1 day trip to any country in lockdown, so you'll want to take advantage of that. And for the worst question, we have a can of spam that we are going to share out to whoever asked that question. Now, first up today, we have Thomas Burr, and Tom is the Vice President of Multifamily Development at One Properties. Tom is responsible for the planning and implementation of strategic multifamily projects. A chartered planning and development surveyor by training, he has over 20 years' experience running complex urban development projects in various markets, including London in the UK, Toronto, and Western Canada. So, Tom, I will leave it over to you. You're first up for us.
Thank you very much, Brian. It's great to be with you today. I'll just get my presentation up and running. And we're good. Okay, as Brian mentioned, I'm VP of Development at One Properties. It's great to be here today. Just to give you a bit of background on One, we've been around since 1987, originally as WAM Developments, and our goal is to create real estate that makes a difference to people's lives. We have offices in Edmonton, which is our headquarters, which is where I am today, and also Calgary and Toronto. We offer services across acquisition, development, property management, and asset management. And we specialize in asset classes including multifamily residential, retail, office, industrial, and mixed use. And there on the right, you can see a few facts and figures by the numbers, including 48 million square feet developed or under development since 1987. Just wanted to highlight a couple of the current projects we're working on. This one here is South Park on White, situated in the heart of White Avenue. We're partnered with the Wheaton Group. It's really a mini master plan over 4 sites. What you can see here is the first building currently under construction. It's 98 apartments situated above 15,000 square feet of retail. We're just wrapping up construction now, and we're excited to be engaging the market and very much looking forward to filling this building up. The next building here is Glenora Park. Now, this is a bit of a diversifier for us. It's a move into luxury retirement and seniors apartments. We're partnered with Rivera, who's the operator of the building. Currently, we're under construction with 290 suites. And it really offers full age-in-place capabilities with seniors apartments, independent supported living, memory care, and assisted living. And what's really special is the location is unique. It's situated high on the river valley with panoramic views of Edmonton's wonderful river valley. The final project here is Jasper Avenue, situated in just west of downtown in Oliver, very close again with fantastic river valley access, close to the promenade and all the amenities that Oliver has to offer. We're partnered with Investors Group, currently under construction with 345 suites and about 8,600 square feet of retail. I think this is a really nice project in terms of scale and size, and it allows us to bring some efficiencies that can allow us to do something really special with the amenities center and the architecture. I think we're proud of in terms of you can see the illuminated bins, which use a Braille motif, commemorating the legacy of CNIB, who occupied the site for a long time. In terms of our perspective on innovation, well, first thing I'd say is real estate has a tendency to be conservative. In the old days, I would say location was everything. It's still important, but it's not enough on its own anymore. And by that, I mean there's increasingly landlords and owners are finding exposure to the operating businesses in the spaces, and the ability to just passively collect rent and let the tenant take care of the business is getting disrupted. There are drivers of innovation. Technological disruption for sure presents both risk and opportunity. Responsible investing is huge. A lot of our institutional partners, be they mutual funds or pension funds, have environmental social governance objectives. Value enhancement is always going to get our attention if there's some tech or new ways of doing things that improves the customer experience. Cost reduction, whether that's on the capex or the life cycle costs over the asset lifespan. We want to be able to make better decision making from better data, and we're always looking to innovate in terms of our tools and processes to make us a more efficient execution. There are barriers to innovation. There's the conservatism or the risk aversion I mentioned, and as well on big projects, they have long gestation periods and tech changes fast. So early commitment may no longer be current when we open the doors. I won't say too much here, but we look at a cost-benefit analysis on any innovative idea that comes forward. We do our due diligence, we evaluate it, and then we come to a decision based on questions like, is it accretive to value? Is the tech ready to be launched? And then is the market ready, which is an important factor for us. And then if we make a commitment, is there a plan B? What happens if it doesn't work out? So what have we done so far? Well, LEED and sustainability is a core part of the mandate. And on our multifamily buildings, LEED Gold is pretty much the standard. Very focused on moving people and improvements there. We've utilized destination dispatch elevators and other measures. Fob and phone access to suites is increasingly being used. Parcel handling, we were finding our operators were spending too much time handling packages, and building information modeling. We want to enable that. The creation of better construction documents is a given now. We insist that on our supply chain. The next stage for us is to look at to what extent we want to invest in attributing models that can give us asset and facility management models over the life of the asset. And then just looking forward, what are we currently interested in? We're interested in, especially in this environment, what we can certify for healthy buildings and possibly into the WELL standard. We're looking at how our portfolio should adjust to work from home, and that's across lots of different asset classes. I'm really interested in parametric engineering models, which the guys at Intuitive will be able to speak to better than me. But in things like envelope material makeup and how do you adjust the dials to create attractive buildings with nice glazing that also meet the energy code. Better data sources, whether that's smart buildings, energy management, or tracking tenant usage of our facilities. And one that's currently looming is Measurements Canada has approved BTU metering now, and we are evaluating the cost, but also whether the market is really ready for that, despite the principle of the user of the utility paying it being a solid one. So thank you very much, Brian. That wraps up what I was going to say, and I'll hand it back to you.
Terrific. Thanks, Tom. Just a reminder too, for those as questions pop up to you, please address them to allison.wood@intuitive.com. You don't want to miss out on our prizes that we have. Next up, we have from Intuitive, Emily King. And Emily is a project coordinator and the sustainable performance lead at Intuitive. She has experience working in projects in various applications, including transportation, institutional, industrial, healthcare, and restoration in and around the Toronto area. So Emily, I'll leave it to you.
Oh, there, unmute. Thank you. Hopefully everybody can hear me and you can see my screen. Okay. So as Brian mentioned, my name is Emily. I'm leading the Sustainable Performance Group at Intuitive, and today I'm going to be talking to you about how we are leveraging technology to be measuring embodied carbon on our projects. So at Intuitive, we strive to engineer for a sustainable future, and understanding the impact that our designs have on the environment and our surrounding communities, we created the Sustainable Performance Group. So this group drives sustainability through all of our services and sectors, and we take a holistic approach and delivery of buildings and infrastructure to make sure that they are future focused, low environmental impact, are high performance, and are beneficial to our people, our clients, and our communities. Through all of our initiatives, we strive for a triple bottom line focus for delivering on environmental, social, and economic sustainability. But above all, we know that we can have a really large impact by significantly reducing the carbon, both embodied and operational, of our projects. So today I'm going to be taking you through our latest tool to measure embodied carbon as early as concept design through our parametric process called Carbon. But first, I wanted to give a quick recap of where we stand today in the climate emergency. So human activities have already caused 1 degree of global warming above pre-industrial levels, and the Intergovernmental Panel on Climate Change released a report in 2018 which revised its previous requirements to limit warming to 2 degrees Celsius to now limiting to 1.5. So this report was written and edited by 91 scientists from 40 countries who analyzed more than 6,000 scientific studies, and it indicates that the serious effects of warming that were estimated at 2 degrees are actually going to come much sooner. Current commitments from countries around the world that have signed onto the Paris Accord will result in emissions that are more than double of what they need to be to limit warming to 1.5 degrees. So to give some perspective, at 1.5 degrees, over 70% of coral reefs will die. 6 million people will be vulnerable to sea rise, 3% reduction in maize harvest each year. 14% of the population will be exposed to extreme heat once in every 5 years. And there is a $54 trillion cost, and that's all at 1.5 degrees. It gets a lot worse than anything above 1.5. So there's absolutely no doubt now is the time to act. There is good news. We can do something about this. As professionals of the built environment, we have a really big role to play in reaching the emissions reductions targets and exceeding them. There is hope. So in the graph that you see on the right, you can see buildings account for almost 40% of global greenhouse gases. 28% of which are operational, and that accounts for the carbon emissions associated with building energy consumption. And 11% are embodied, which is measured as global warming potential. And this accounts for the carbon emissions associated with the manufacture, transport, and installation of construction materials. However, the portion that's associated with the operational carbon is expected to significantly decrease in the coming years as buildings continue to have better operational performance, which means that embodied carbon is going to start to occupy a much bigger piece of that pie. As designers and professionals of the built environment, we want to know what we can and should be doing about this. So the World Green Building Council's Bringing Embodied Carbon Upfront publication provides some really fantastic guidance on required actions for all stakeholders that are involved. So as you can see in the graph on the right, to have the most impact on reducing carbon, of course, the best option would be to build nothing and instead look for suitable alternatives. But if building is required, then the next best would be to explore options for reusing existing structures and materials wherever possible. And then when designing, optimize as much as possible to reduce the new materials and to use low carbon materials. And that's where we're going to be focusing today. One design approach for reducing embodied carbon would be through optimized material selection, and there are some examples there on the left. And another option would be to make more informed design decisions that result in reducing the material quantities. So with all of these things in mind, and knowing that the biggest opportunities for carbon reductions take place in the earliest stages of design, we wanted to develop a tool that would help us quickly and efficiently quantify those materials in concept design before a Revit model is even started. And so with that information, we could then apply the global warming potential, which is the embodied carbon, of those materials and arrive at an estimated embodied carbon for the building or structure from which we can then make informed design decisions going forward. Enter Intuitive's Carbon Tool. So this is a parametric tool that uses Rhino and Grasshopper, and the tool was developed around 3 key goals. So first, it has to be easy to use for collaboration in client and design team meetings, and it has to generate results quickly. It has to calculate material quantities and the embodied carbon of both the structure and the building envelope. And finally, it has to complete concept level design checks to ensure that the generated structure is valid. And we can use this tool to analyze concrete, steel, or timber structures. So I'm going to take you through a quick case study of a 4-story commercial building to show you the functionality of the tool. So this building was originally intended to be a concrete structure, which we're considering as the baseline. And we wanted to evaluate the building from a timber and steel perspective as well. So each scheme does have some common concrete elements, such as foundations, columns, below grade, level 1 slab, and below grade slabs in the central core. So to start, we create or import an architectural form from Rhino and define the structural material type, so concrete, steel, or timber. And then we can select a set of unique use cases to define the loading, the floor height, and the number of floors per use case. Next, we define the column shape, the spacing, and the layout, and the column size or strength of the material is automatically designed in the program. We also define and place a central rectangular core, which removes columns as required. And other partitions can also be added, and all the wall thicknesses are defined. Next, we define the beam parameters and spacing and define the deck parameters, and the framing is all automatically generated and the beams are all designed for strength. And finally, for structure, we define the design parameters for the foundations. So currently we use a simple pad footing design, but we're in the works of adding other foundation options, including piles and raft slabs. Next, we add in the cladding options. And so these options can be defined per use case, and we can define the percentage of each cladding type per use case. And each cladding type will affect the loading and then the total embodied carbon. Finally, we arrive at our embodied carbon estimates. So the quantities of each material are tallied and the global warming potential of each material is applied. And these results can be broken down by material type, element type, use case, or floor number. And then the embodied carbon values will update when the various design parameters are adjusted. So for this case study, we compared the embodied carbon of each scheme. And one commonality that you can see across all three schemes was that the slabs, unsurprisingly, had the most carbon. And so remember, there was concrete that was common across all 3 schemes. And so, and there was concrete in each of those schemes. And so from that, we can then make some design decisions to reduce that amount of concrete where possible. And then we can also look for ways to reduce the embodied carbon of the concrete by increasing SCMs, using Portland limestone cement, or other innovating technologies to reduce cement content. So these graphs show the embodied carbon as a percentage of the total for each scheme. And when compared to baseline, the timber scheme had a 31% reduction in embodied carbon, and the steel scheme had a 24% reduction. So really the biggest benefit to using this tool is that it's really quick and agile, and it allows us to quantify multiple concept designs relatively quickly since all element sizing is automated, which is different from current tools that are out there where the user actually needs to determine the structural sizes. So this tool is constantly being improved and expanded, and some of our future plans include creating a hybrid superstructure option to find an optimal balance between timber, steel, and concrete elements. We want to continue adding to our EPD database of materials, and we are expanding the concrete scheme option since right now it just looks at flat plate. And then we want to build more foundation options in addition to pad footings to include piles, caissons, raft slabs. So stay tuned for future updates on the Carbon tool from us, and thank you. And if you have any questions, please reach out to me or to the Sustainable Performance Group. And Brian, I'll throw it back to you.
Terrific. Thank you, Emily. All righty, and moving straight along, our next presenter, Tom currently manages a construction technology consulting practice, acts on the board of directors for several startups, and is currently the president and CEO of CanBIM, which is Canada's largest building and infrastructure-focused technology and innovation organization. As a construction industry consultant, Thomas helps Canada's most advanced builders develop new innovations to create new profits and remain competitive. Tom, over to you.
Great. You can hear me and see my screen?
Yep, you're looking fantastic, son.
Thank you very much. Thank you very much for the opportunity to speak today. I'm going to pick a bit of an edgy topic. Going to try to attack this in a very succinct way. But the edge of obsolescence, how technology is redefining the building industry. So, obsolescence is the state of being in which occurs when a service or practice is no longer needed, even though it may still be in working order. And I think that the technology is really influencing the services that we provide as general contractors. So I'm going to talk a little bit about these four areas. One is market condition knowledge. So I think owners rely on general contractors for their relationships with the supply chain, their knowledge of all the moving parts within the supply chain, who's capable of what, et cetera. Pre-construction planning, so obviously getting involved with a project during the early stages and providing input into the design. Supply chain management, so your ability to actually manage the activities on site and make sure that all the material that's going to be arriving to the site arrives on time and is of the proper quality. And then management of site activities themselves, like actually planning day to day and adjusting the plan with all the moving parts. So I'm going to try to hit this with three major points. Number one, everyone and everything is now a data point. So on a construction project, you've got literally thousands of individuals, many pieces of material, lots of moving parts, and all of these transactions are now being recorded into digital systems, and a lot of which is now planned in a BIM environment and whatnot. So what we have to understand is that every single thing on a project can be measured and tracked and understood. And then an important trend to understand there is that the cost of this data acquisition over time is coming down significantly. And I think we're just starting to see that. I mean, as everyone's got, we move from BlackBerries to cell phones, but moreover, now we're digitizing our projects at the early stages in a BIM environment and then connecting that to our systems. So just kind of a quick example, this is a Leica P50. These retail for about $150,000. You need $20,000 in software, a $10,000 computer and an $80,000 paid individual to actually operate the system. And this year, Apple's going to be releasing an iPhone with a LiDAR scanner built into it. So we're seeing these, major steps in simplifying how we're collecting data and making it easier to collect. This is a UAV that Amazon's releasing this year for $250. You can have a security camera that flies around your home. So it's very easy to understand how these things can bridge to an active construction site and provide a lot of value as it relates to data collection. And then, of course, there's a whole class of software technologies that integrate all this information to one place, giving the construction manager or whoever's in charge of that job total insight into all the real-time activities and data that's flowing on their project. This one's called Reconstruct. So the second major point I want to make is that your software knows you better than you know yourself, in that it's collecting data about everything you do and it can actually process that data and give you recommendations better than you can do that in a manual way. So if we look at that, again, on a bit of a graph here, looking at speed and accuracy against time, if you look at manual planning, I don't think there's been a significant increase in efficiency or productivity as it relates to all manual planning. And I include scheduling and estimating, potentially even design in that category. And I think over time, that's actually getting worse as, the people with all these skills and experience are retiring out of the workforce, and our projects are getting more and more complicated. And I think that's what's going to happen, and what we're going to see very quickly here is that data-enabled automation, the tools, the AI, and all these platforms are going to actually accelerate way beyond what we're currently capable of using our manual processes. So, as an example, kind of looking at the planning fallacy, this idea that we can think about a construction project in a cascade of activities. The reality of that is significantly different. I mean, on a project, you've got many, many moving parts, many, many variable factors, and all we can really do is project, the best path forward, and then bob and weave as we go forward. So the big difference here is that the software, because it has access to our data in real time, can actually provide better recommendations than what we can develop for ourselves. So just a few examples of this, there's a whole class of estimating tools that connect with our models. Now that we're generating models of the geometry of the building that we're going to build, we can actually take that 3D model, we can compare it against our historical productivity rates and all of our unit costs, and the system will actually spit out a pretty decent estimate almost instantly. The challenge with this is that, as a GC, you're using someone else's platform and someone else's formula and potentially someone else's database of unit costs. The same sort of things happening in design, where we see generative design now being, a tool that's being used on a regular basis to solve for design. The challenge with this, again, you can set the parameters, but you're using someone else's platform. You're using someone else's design algorithm. So it's really changing the nature of what you provide as a service. And we're seeing that generative design concept now being applied to scheduling, where with a 3D model and your productivity rates and the recipes of how the sequence of events needs to occur on a job, you can actually, pay a small percentage of your project value and have an AI generate millions of different scheduling scenarios and allow you to pick the most optimal sequence of events for your project. The third point I want to make is no middleman is safe in a digital economy. So I do think that general contractors, they're in the middle of, connecting the client who wants to build something to ultimately the end user who's going to occupy it. And, we're seeing that over time that, all these new technology products and services that are emerging, there's almost like a logarithmic effect here where these new technologies are focused on disintermediation. So the idea of cutting out the middleman and connecting the customer directly to the client. So some examples of this, Autodesk purchased Building Connected a couple of years ago for about $600 million, somewhere in that range. Probably have that wrong, but significant amount of money. It's a really fantastic tool for tendering. General contractor can now tender with total control and visibility, manage all those transactional discussions between their supply chain. Unfortunately, you're doing that on someone else's platform. You're doing that potentially with someone else's black book. So you could see how that can lead to, say, Uberitization. And the beauty of using systems like this is that you get your historical information is now cataloged and organized for your use. But again, if you're storing information in the cloud on someone else's product, you're storing information, your data, on someone else's computer. And supply chain management system. So, Jovix is an example, huge platform. What they do, and you invite them into your project, they'll go out and they'll certify your suppliers. They'll set up Wi-Fi beacons all over the factory. They'll put an RFID tag on every single element that's being fabricated. And now you have total visibility in your supply chain from fabrication through delivery onto the job site, and then all the points of transaction where you need to check for quality and whatnot. Unfortunately, again, you're doing this on someone else's platform and you're certifying them on that platform. So every time you give away some of this responsibility, you're giving away a bit of the service that you used to provide. And this is, an example here from Alibaba where you can order just a kit of parts and assemble this vehicle. But this is very applicable to our world now, where we're designing for manufacturing and assembly. we want to actually reform our supply chain. So we're buying elements that will assemble on the job site, which will greatly simplify design and procurement and construction. However, you're creating an environment where you're going to be building using someone else's kit of parts or their intellectual property. So those are my three major points. So it's not all murky and dark. I do think that general contractors definitely have a place, and they're going to continue to have a place. But I think that there's a real need to think about the technology that you're introducing into your technology stack for your business, and think about the data that you're giving away. And as you procure those systems, you need to think carefully about those relationships that you're developing, making sure that you have interoperability, making sure that you can extract the data, and making sure that the culture that you're creating within your business as you digitize your work and inject these systems into your business, you need to be able to be prepared to move and turn on a dime and replace those systems with other systems as required in your technology stack. So that's my quick 6 minutes, but I'm looking forward to the discussion. Thanks, Brian.
All right, thanks, Tom. For those of you watching at home or in your office, I think your hats are starting to fly off now. We're picking up speed, and the technology is getting quite interesting. Next up, we've got from Intuitive our own Matt Smith. Matt's proficient in various structural engineering analysis packages and knows from first principles how fire influences structural and life safety systems. Where required, he makes use of finite element software such as Sapphire, fire modeling software such as Fire Dynamic Simulator, and agent-based crowd simulation software such as Mass Motion. He has experience in analyzing new and existing structures for the impact of realistic fire events, and actually most recently for COVID-19 and social distancing protocols. So Matt, I'll leave it to you to take it away.
All right, thanks, Brian. Just a quick sound and video check. Can you see my screen okay?
Yeah, looking good. Sounding good. You
right,
look
so
fantastic, actually. Your hair is exceptional today.
That's what I was looking for, was a compliment to get started. So in keeping with the theme of today, I'm going to be looking at shaping the built environment, leveraging new opportunities with technology, but specifically I want to look at pedestrian modeling. And as Brian mentioned, how we're using this, not just to look at the day-to-day scenarios for our projects, but how we can leverage this to make our communities and our infrastructure more resilient to future events. And so what is pedestrian modeling? It's the analysis of how people move within our built environment, and we do this to quantify movement patterns, travel times, or areas of crowding and queuing. The animation you see on the right is one of the large transit projects we worked on, and this in many ways is one of the typical uses for pedestrian modeling. It's any type of building or infrastructure with large volumes of people where we want to model those people and make sure how they move through that space is comfortable and safe. And so essentially what it allows us to do is, as the design team, it allows us to quantify and visualize the user experience. In terms of quantifying that, some of the traditional metrics that we've seen in the past, first and foremost is density. You may have heard of this referred to as level of service. But when we model a space, what we're looking at is how dense are the people in a given area. The more dense they are, then the slower they're moving and the less likely they are to actually take their desired path. And so the greater the density, the lower the level of service. We can also look at travel time. So how long does it take someone to get from point A to point B? And what does that look like on average for all of the occupants? We can look at processing times. So if you look at an event center, for example, how long does it take you on average to get from the gate to your seat? For an airport, we might look at how long does it take you to get from curbside to your final gate. So any sort of processing time that we want to look at. We can look at evacuation time as well. So in the event of a fire, how long does it take people on average to evacuate? And what is the worst case evacuation time? And is that still safe? And then we can look at construction sequencing. So as we introduce different layouts of hoarding, or as we open and close different areas of the building or the infrastructure, what is the impact on how people move through that space? And so these are the traditional metrics that we would have seen in the past. What I want to look at now is how might we use pedestrian modeling to respond to the current pandemic that we're going through. So this image here I took from the World Health Organization. It's the different phases of the pandemic, which we have all gone through together in different ways. But this y-axis you can think of as the impact of the pandemic. And so we had this worst case point where there was an extremely large impact on all of our businesses and all of our infrastructure. There was some transition phase, and then eventually we were able to adapt to that and now we have a new normal that we're living through. But if we think of what the impact of this was on our businesses or our communities, we can look at a graph like this where we can sort of map out the performance. And so before, call this middle of March, we were all ticking along at about 100% performance. And then it almost seemed like overnight everything shut down as a result of this pandemic. And so we had an immediate drop in performance. And then this recovery would have looked quite different depending on what sort of business you were, what sort of asset you were managing. But there was some recovery phase after this drop in performance. And so what we want to understand is how might we leverage pedestrian modeling so that we don't have such a drop in performance, or so that we can recover quicker so that we have a shorter duration of that low performance. And so I mentioned the traditional metrics, and what we've seen through COVID is we do have new opportunities. These are things that we've seen in the news of how people are responding to the pandemic to get back to work or to get people back on transit, different mitigation measures to mitigate or to lower the risk of transmission. And so what we've seen is certainly physical distancing. In the context of pedestrian modeling, we call this proximity analysis. We can also look at how long were people within close proximity. They might violate that 2-meter recommendation, but for how long are they doing this? And we can also look at for how long are people within a certain area. And so the graphic at the bottom is an example of a university project we worked on where we want to introduce different mitigation measures. So in this case, we had one-way stairs as opposed to two-way stairs. We introduced a new scheduling for the classrooms that we don't have a massive change on the hour, but rather spread on 15 or 30-minute increments. And what we can do with this model is actually test our mitigation measures and see if they have lowered any of these metrics, if they have allowed people to maintain physical distancing, if they have lowered the time spent in proximity, and if they have lowered the time spent in high-risk areas. And so essentially what we want to do is use pedestrian modeling to test, compare, and quantify the effectiveness of different mitigation measures for a range of scenarios. Right now, we're looking at this in the context of COVID, but even before this, pedestrian modeling was used for a range of scenarios. If we think of fire, for example, and we look at evacuation modeling, what we're doing there is modeling a building in a fire scenario to figure out how effective is our egress strategy, and are there things that we can do as a design team to improve that evacuation. And so if we're using pedestrian modeling to test different mitigation measures, how we might think of that related to resilience is if we think of this baseline curve. So this is the performance curve. We have an initial drop in performance when a given event happens. We could have one scenario where through modeling and other mitigation measures, we can reduce the initial impact of that. So we don't have such a drop in performance, but we might have the same recovery phase afterwards. And an example of this for pedestrian modeling might be an event center, where if we proactively have mitigation measures such that we don't drop to 0 occupants, but we might have 25% of our attendance, then we don't have such a big drop in performance. We still have some operation happening when that event occurs. Another scenario we might think of is an improved recovery. So this might be something, this might be transit, for example, where an event happens, we have this immediate drop in performance, and that's related to a lot of external factors. If nobody has anywhere to go, then we're going to have this immediate drop in performance of the transit systems. But if we can use pedestrian modeling to demonstrate how have we mitigated that risk of transmission, we restore the public confidence in using that transit, then we might see a much quicker recovery until we're back to 100% performance. And so these are different scenarios we can think of where we can leverage pedestrian modeling to inform our mitigation measures ahead of time, such that we don't have such a drop in performance or we have a quicker recovery for a given event. And so to wrap up, what I would say is that COVID-19, it's certainly placed a greater awareness on how people use and interact with their built environment. We've already seen this in RFPs. One of the biggest pedestrian modeling jobs that we have in the office right now, the RFP actually asked how will the design team respond to COVID and how will they respond to future pandemics? And one of the things that we put forward as a differentiator was we're going to use pedestrian modeling to actually test our mitigation measures ahead of time to make sure they are effective and that we are able to respond to this should it happen again. And so all to say that we as a design community, we must respond to these new expectations. There's new expectations of how people will move through our spaces and how they interact with them. And we do have the tools to be able to respond to this, both for new buildings and for existing buildings. So with that, pass it back to Brian. But looking forward to questions at the end.
Great. Thanks so much, Matt. Next up, we have Dr. Mike Kennedy. Mike is a founder, high-tech executive, and technology strategist with a deep startup and academic background in geospatial location-based services, applied machine learning, software development, and distributed networks and sensor systems. Mike thrives and excels at taking technology innovations to environmental and social problems from concept to market, and successfully managing exciting teams, both small and large, to achieve meaningful outcomes for the planet. Mike, I'm going to hand it over to you. There we go. We find him. Did we lose Mike?
Oh, I'm here, Brian. Thank
There
you.
we go.
Yeah, just in my screen here. Thank you so much for the introduction, and thank you to Intuitive for the opportunity to present today. And I'm really excited to hear what some of the others have been working on. And of course, now I'm having technical difficulties launching my PowerPoint. It was working before.
You do look fantastic, Mike, though. I've got to tell you, from an
Thanks.
organizational standpoint, I think you're probably the most attractive speaker we've had today. Oh, there we go. That bought
Okay.
some time.
Thank you for that. And I apologize, challenges here. So what I want to present about is a software as a service application that our firm has been developing and recently partnered with Intuitive on, and really speaks to some of what the other speakers have touched on. Both the digital economy is moving on us. In different circles, some folks are arguing that COVID has pushed us 10 years ahead of what we would have otherwise been doing in terms of moving forward our digital strategies. And so what I want to touch on today is, are you seeing my presentation okay, Brian? I'm getting a warning here.
Yeah, we've got your data-driven investment screen up.
Apologies. So, the problem that we're all facing, and I think Emily set this up really nicely, is we're dealing with climate change. We are dealing with increased costs of operating buildings, and of course, right now under COVID, those costs are still there, and many of us are not using the buildings. And buildings can be a massive part of Canada's climate change strategy and a global climate change strategy. But we have a bit of a problem here that we see in larger parts of our society, which is there's not an equal distribution of resources across the building stock, which means that we have some building stock that is well equipped with technology, is high performant building technology, and we've got some real leaders in this area. But then there's the majority of the building stock, which is all the stuff that most of us live and work in. And I classify the buildings under 200,000 square feet, where there's very little technology. We're talking about electrical panels and bare wiring and nothing in the way of automation or systems. And that, to me, is a big problem, a big challenge that I think technology, and particularly artificial intelligence, can help us with. And the stars are starting to align. Energy costs are rising, which is a challenge as we shift our energy grids from fossil fuel intensive grids to less fossil fuel intensive grids. Environmental concern is higher than it's ever been in history. And I mean, the fact that for me, being on a panel in the engineering firm is introducing the environmental problem is a first and one of many going forward. And it's we're seeing progress in this area. But meanwhile, the cost of electronic devices and what we call the Internet of Things is going down. We're manufacturing more, chips are getting cheaper, shipping is getting cheaper. And now we're looking at new models. So as the first presenter mentioned, the fact that the real estate industry is really concerned with the type of capital they're procuring and the social consequences of that capital is a trend that started 15 years ago, but is really coming to the fore today. And it's really important, not only what you're doing with your capital, but and how you're going to use your capital in the future. And so, as I mentioned, the building sector is quite disparate in terms of the equality of resources, and which means that we can bring new technologies to start to level the playing field for all buildings. And when I when I throw out the word artificial intelligence, and maybe Corey will touch on this after me more detail. When I look at the construction sector, I see there are going to be, real future opportunities for what we call general artificial intelligence. And this is the one we see in the movies. This is the one that gets us really creeped out. And it's the artificial intelligence where things are acting autonomously based on instructions that they're learning as they go. The kind of artificial intelligence that I'm talking about and we've been working on, and I think we all need to continue to work on, is around expert-assisted artificial intelligence. So this is bringing the technology and the people along with us on the journey of learning and building out new solutions.
Mike,
Yeah.
just a note, your screen's not moving there. So, but fortunately, your your discussion is working very well. So I just wanted to let you know.
I have beautiful slides in front of me. You guys can't see. I really apologize for that, but
yeah, no worries.
I'll continue on. Hopefully, the narrative is captured.
Oh yeah, no, it's been great.
But with a disparate amount of buildings of different character and quality and performance, really becomes an opportunity to bring automation of data and systems to bear to unleash actionable insights in buildings that otherwise won't be there because we can't aggregate the data, or if we try to bring all of this information in, it becomes more than we can consume. And I think this was touched on in an earlier presentation, is that we're going to have to, over the next little while, as we build these new technologies, balance this weird position between, where we are with buildings right now, the non-high performance buildings, which is we don't have a lot of data. We don't have aggregated databases. We don't have standardized databases. We don't have live streaming data coming in for these buildings, to a future point when we're going to be drowning in data, and how do we start to organize it and structure it? And this is where I do think there's lots of opportunity for new technologies, and where we've been focused around with the product of BuildSense is put together some basic digital infrastructure that allows us to transmit data, to store data, to process it, to secure it, and make it available to whoever needs it with the utmost of security and privacy. And then to leverage the new opportunities that are coming about. So mobile cloud computing is this ability to instantaneously communicate from device to device, from device to cloud, in speeds and amounts of data that we've never been able to address before. And then organize that data to help folks like Brian and other folks making decisions about buildings to make sense of that. And what else is super exciting is that market incentives are starting to align. So if you're following the news federally, we're going to see lots of funding going into building retrofits, and hopefully, that money will move sooner rather than later. But that becomes an opportunity to see alignment with identifying where in the buildings that we manage are the real opportunities for return on investments and paybacks under 10 years, but moving technology and retrofits into buildings in a scale that we've never done before. And to bring the talent and training along with it, so that folks that used to work in traditional, perhaps oil and gas industries, now become energy integration specialists in buildings, or advancing energy auditing sector in a way that is fast and scalable. And so with the BuildSense technology, which you cannot see the screens, obviously, which is unfortunate, we have started to structure the data for buildings in a way that leverages the energy audit in a way that we haven't done before, to fast track and keep the cost of building benchmarking down, and then to move buildings from just whether it's a new commissioned building and we're measuring its base performance, or an existing building that we're looking to examine retrofit opportunities, is move that decision making and speed at which those retrofits will get defined and validated very quickly. And it's done by starting with both basic utility and building information and databases that we've developed, to machine learning algorithms that start to predict which energy conservation measures are going to make the most sense, and then which design choices come out on top in terms of the financial performance. And all of that same data, we need to make decisions, but also to validate funding applications, to validate capital requirement demands from banks and others, to show that we're measuring the performance of buildings, their contribution to greenhouse gas emissions, both today and into the future. And then to deploy low-cost IoT to these buildings, devices that do capture thermal load by room, that 15-minute interval energy, electricity consumption use in these buildings, which further brings back more learnings to a data platform and gives us further and further accuracy and prediction about what needs to happen in buildings today and in their near future, so that capital gets deployed faster and at a much lower cost than it is now. So maybe I'll stop there, Brian. Again, I'm not sure what happened with the slides, but I'll pause there.
We ended up with one at the end that flipped over, so it's a shot of your laptop there, but people will know how to get in touch with you if they want to see more on this for sure. Thanks very much, Mike. And then finally, today we have, last but not least, Mr. Corey Jansen. Corey is a co-founder and co-CEO of AltaML, a developer of machine learning applications. Previously, Corey was co-founder of Investopedia.com, a financial education site that provided content and tools to help educate individual investors. From its founding in 1999, Investopedia became one of the most popular financial sites on the web and was sold to Forbes Media in 2007. The business model for Investopedia was then replicated through JanAlta Interactive Inc., a holding company for digital media properties. Corey, we'll hand it over to you. And we can see your screen. That's good.
Thank you so much, Brian. And I'm kind of the outsider for the industry. We, as a pure play AI company, we have a lot of partnerships with companies in the AEC. And so my goal with the presentation here is to really give a quick overview of AI, but then touch on a few projects we've worked on, if for no other reason than to spark some interest in where this might be a fit in your organization. What you have on the screen right now is a chart from McKinsey. As you might imagine, and unfortunately, the industry is at the bottom of the pack in terms of current AI adoption and in terms of spend. I like to think of this in maybe a more optimistic point of view, that just means there's that much more opportunity. Reference this beforehand, the term, all this alphabet soup that you hear in the media. Let me simplify it very quickly. And we sometimes spend about 20 minutes going over this in great detail, but think of AI as this umbrella term that is so generic that almost has no meaning. It can have that Hollywood robotic flair to it, but it really is this umbrella term, of which the largest piece that really matters to a business audience is machine learning, or ML. So this is when we have software or computer programs that can adapt without being explicitly programmed. And so what that means is, if you know the rules for what you're trying to do, you just need to program it. Machine learning is when we're finding those patterns within the data that a human might otherwise find it difficult to identify. And deep learning is where all the fun stuff is happening. So when you see autonomous driving or the stuff with drones that were mentioned in previous presentation, this is where a lot of the breakthroughs are really happening. Most organizations, however, are taking on machine learning projects. Canada is actually a world leader. Sitting here in Edmonton, do a little bit of bragging from Edmonton and Calgary and the Alberta perspective. Outside of the Valley and London and Beijing, Toronto and Montreal are really world leaders in terms of some of the academic excellence. But a lot of people don't realize that the University of Alberta is actually right up there. So I included this chart to show that research prowess that we have locally here in Canada. The reason this is significant is that it's creating a pipeline of talent that is second to none anywhere in the world. Now I'll pop into a few of the examples. So here's one use case we really like with Kleinfelder, that was with one of the majors in Fort McMurray. You can sort of see the red dots on the image there. What we were doing is we actually took their 3D building models And we were trying to identify, when that was overlaid with images in the building, where there might be insulation at risk from corrosion or at risk of falling. The reason this project came about was because there was unfortunately a near miss. By using computer vision in this way, we actually were able to not just keep workers safer for a cheaper cost, but do so in a way that wouldn't have been possible without that computer vision. Another example here, I mean, again, a little bit adjacent to construction or engineering, but we've done this in a number of different areas. A previous speaker talked about that's 55 or 60-year-old person who's leaving the industry. Well, we see that happening all over when we can actually use predictive models to try to say, what are the operators that are actually able to actually perform that task in the best way? This can either be used to then help train those people in terms of how they can improve, or it can actually serve as a tool to help guide through that process. We've done that both with site superintendents, operators on wireline wells, a number of different areas. Another project we worked on was actually on wind prediction in terms of RFPs with an engineering firm. This isn't going to work on the Stantec Tower and when you're talking about the big projects, but when you have high volume projects or a high volume of bids with a lot of data, we've actually been able to show that we can actually predict the likelihood of an RFP in certain areas, and it's the first step towards being able to then optimize for price. And last example here, I'll talk about, it was actually, we've done this both with large general contractors as well as utilities. Again, back on safety, right? Being able to actually take a look at those reams of safety data that we have on site. Once they're digitized, being able to actually use those to have predictive models for what type of projects our workers are most at risk with. So ran through those really quickly. I know we're running a little bit over here. We're right at the top of the hour. My hope here is that these a quick spin through some projects that we've worked on might show some inspiration, in terms of your work and where AI isn't just happening in the future, but is actually taking effect in projects today. Thanks.
Great. Well, thank you, Corey. And yes, as you mentioned, we are right at the top of the hour. And as far as questions go, I don't like to drag this out so that we've got everybody wanting to leave or coming or going. I think the key thing is here, if you do have questions, we can reach out directly. You can reach out through me or through Allison, and we can connect you to any one of the speakers here. I think the big takeaway today, our topic was shaping the built environment of the future. And I think we got a pretty good glimpse of what that's going to start looking like. And data is a huge part of it. Climate change is a huge part of it, and partnership between constructors, developers, engineering, and architects are all fundamental to come together in this process. And so, listen, on behalf of everyone here at Intuitive, thank you to our guest speakers today. You all did a terrific job. And, we got a question here. Where did I get those suspenders? Well, that's our first question. And that, as we mentioned, there is a prize. That one gets the can of Spam. And the all expenses paid trip to a country in lockdown will go unclaimed. All right, so thank you, everyone. Enjoy the rest of your day, and good luck with this pandemic, but keep on pushing forward. Thanks, and good afternoon.